Okay, let's look at question 6. So a weather balloon is filled with 15 liters. Okay, so I just go through. Okay, so it has 15 liters of helium at a temperature of 25 degrees Celsius. I'm just going to add 273 here because I'm pretty sure that that's what I did on the key after doing that last problem, 2 problems ago. All right, and a pressure. Okay, so this we have all 3 of the 4 variables here. What is the new pressure in millimeters of mercury? And that will be good because I'm already in millimeters of mercury. If the helium in the upper atmosphere where the temperature is negative 35 degrees. So let's say negative 35 plus 273. $238. And the volume becomes 34 milliliters. 34 liters. Then it tells me that the amount is constant, which we're going to use the combined gas law, which has each one of the variables. And it really is all the gas laws combined. And so in this case, we don't talk about the variables being directly or inversely proportional because we're changing multiple things. So we'd have to think a little bit more about it. So that's not usually how I think about this one. In order to figure out what the new pressure is, we'll have to plug in what we were given. So let's plug in the left-hand side. So pressure 1 times volume 1 divided by temperature 1. And this equals pressure 2, which I don't know, times volume 2 divided by temperature 2. Now, at this point, really, in all honesty, you should pause and try to solve it. Like if you're having to watch the video because you didn't know where to start, at this point, I would pause, try to solve it, and then see what happens because I tend to rearrange and then plug into my calculator, where you might like to start simplifying by doing the math. So like the whole left side of this equation over here, that's just numbers. So you actually could plug that in and get a number. And so I like you to practice your math, like how you would think through it, because you don't have to do it the way I do. There's different approaches to solving for in this case, P2. So I'm going to rearrange. So the first thing I would do is I want a marker, not the highlighter. I'm going to cross multiply the 238 over. So now I would have on the top 238 Kelvin. So I multiplied it over times 685 millimeters of mercury, which was already there, times the 15, and then divided by the 298. So at this moment, I just took this number and multiplied it over to this side. And that would equal now the P2 times the 34. And then to get the 34 to the other side, I'm going to divide both sides by it. So I would have 238 on the top times 685 times 15. I hope I'm not getting so low you can't see the closed captioning. Then I still have the 298 Kelvin, but I'm going to divide this 34 to the other side. Now, one thing I would encourage you to do now is when you plug it into your calculator, you need to have parentheses around this. Okay, because you want to multiply those two numbers before you divide. Then the other thing we can see happening is how the units cancel. So Kelvin cancels with Kelvin, liters cancels with liters, and now what I have left is millimeters of mercury, which is a pressure. So I will have 238 times 685 times 15. So I multiplied all the numerator. Then I'm going to divide that by, and in a parentheses, I'm going to put 34 times 298. And I'm going to close my parentheses. And I get as my answer for my pressure, I get 241.35. So to three significant figures, I'd say 241 millimeters of mercury. Now again, you might arrange differently to solve for P2. So what I want you to do is go back to this part right here, and on your paper, I want you to practice rearranging how you would rearrange to get the correct answer. Like I said, there's different approaches. You could simplify first and then rearrange, or I rearrange and then simplify. So that part is just dependent on how your brain will most easily navigate the math of the problem.